So if you're a fan of MotoIQ, you're probably used to coming here to see how to make things fast. Fast engines, more power, more torque. Well, today we're going to do something completely different. We're building a Jeep motor for off-road use. So the Jeep inline-6 motor is known for its ability to make tremendous off-idle chugging torque. That's why it's so popular for off-road and even crawling and stuff like that. So we're building a Jeep motor that'll be even better for this kind of use. We're going to start with the 4-liter inline-6. Now this motor is the mainstay of Jeeping and off-roading. It's a really popular engine for this use, and we're going to do stuff to increase the torque and make it even better for off-road. We're also going to make it so it'll have a long, trouble-free life. So we're going to start with the block. You know, it's kind of a pedestrian cast iron block, but that's good. You know, this thing isn't going to be revving or doing anything crazy, so cast iron's fine. It's reliable, strong, pretty bulletproof. To make it more bulletproof, we cryogenically treated it and then treated the bores to WPC. The cryogenic treating stress relieves the block and converts like austenite in the iron to martensite, which is a kind of a harder molecular structure. This will make the bores more abrasion resistant and longer lasting. And when you combine it with the WPC, this is going to be something that's going to last quite a while, especially since it's not like high revving or anything like some of our race motors. We bored it with a torque plate. That way we keep the distortion with the head bolted on to the minimum. When you machine with a torque plate, it warps the block in the same way bolting the head will do. So when you bolt the head on, the bores become round. You get better piston ring seal, quicker break-in, longer life, more concentric bore in the as-used condition. So a torque plate is a good step that a lot of engine builders skip, but we find it makes a pretty good difference. I guess if we look at the bottom end, so mostly we're OEM here. Of course, we inspected everything to make sure it's in good shape, and then the registers of the block are good, nice and tight. We did a check for to see if this thing needed an align bore or an align hone. Usually these old school iron blocks, usually they don't shift around that much. Everything was good. For bearings, there isn't much in the high performance market for bearings on these motors. So what we did is we got the OEM bearings and we WPC treated them. Now the WPC treating can increase the load bearing capacity of any bearing by about 20%. So this is almost like getting a race bearing out of the stock bearings. So it kind of refines the structure, kind of gives it some surface hardening, much the same as getting a performance bearing. So a 20% increase in load bearing capacity, that's pretty significant. Since this thing's not revving to the moon, you don't see things like we didn't do ARP studs or do anything super trick because you don't really need it. This is an off-road motor, so stock stuff is just fine for this application. So next is the bottom end. This is where all the cool stuff happens, and it's not really that expensive. When you're making an engine that makes a lot of torque, one of the things you want to do is increase the stroke. Increasing the stroke gives you a bigger lever arm for the piston to work on. That increases torque. It also increases your port velocity and things, so that increases torque too. It's not good for revving, but we're not building an engine to rev. So what we're going to use here is a crank from a 4.2 liter Jeep motor. Now this motor isn't quite as performance oriented. The ports in the cylinder head aren't as good, for instance, but the crank is a lot longer stroke. It drops right in. When you pair it with a slight 30 thousandths over bore, which is nothing for an iron block like this Jeep block, you end up with almost 4.7 liters. Now that's a big gain in displacement for not that much money. Of course, we put our own touches on the crank to help with longer life. First thing we do is we chamfer all the oil holes, so that acts like a little reservoir where the oil's coming out. Plus, it reduces any chance of damaging the bearings. We cryo treat it and WPC it. Now, WPC and cryo isn't totally necessary because this is a low RPM motor, but the cryo helps with wear on the journals, makes it more abrasion resistant, stress relieves it, and the WPC makes a nice hard wear resistant surface that has really low friction. So it doesn't really hurt to do it, especially while everything's all apart. It just assures everything's going to last a lot longer. We balance the crank. There's really nothing else special about it. It's not a trick racing crank, but hey, you don't need it for low RPM and torque. The next thing we're using are these scat rods. Now these scat rods are not like a super trick race rod, but they are a forging that's a little bit beefier than stock. Has bronze bushings for a floating pin. Best of all, it has ARP bolts. Now this is a rod that's a lot stronger than stock, but it's pretty inexpensive. I mean, we're not revving to the moon, so we don't need like a super trick racing rod. It's kind of a waste of money in this application, but this is a lot stronger. Next, we're going to our piston. We're using a forged piston. It has a dish in it, but it's still pretty reasonable compression. Like, since we're stroking the motor so much, you have to make up some combustion chamber space so our compression doesn't get too high. So we're shooting for like 10-to-1 so we can run pump gas and all that, no problem. So it's a nice dish piston, has quench pads. We'll get more into that later. But it's not like super trick. It has a pressure equalization groove between the ring grooves. It doesn't have a super crazy, super narrow ring, but that's good for long life. It has like a bevel cut here on top of the ring groove to help pressure get around the ring for better seal. I mean, it's a good solid forged piston, but it's perfect for this motor. So we also WPC treated the piston rings, and the ring grooves. Now this all gives less friction and longer life to everything. We have this other pretty good advantage that the WPC treated ring grooves prevent micro welding of the ring to the piston itself, and when the rings are freer to move around and stuff, they can conform better to the cylinder walls and get better ring seal. Now for the rod bearings, we used King bearings, but King doesn't make a Super Trick tri-metal high performance bearing for this particular motor. This is more like an OE replacement bearing, but what we like about King is the shells come in more sizes than what's commonly available, so we can do a better job of getting the precise oil clearance. Now, you might be surprised that we're not using trick bearings in this motor. I mean, there's kind of two reasons. One, nobody makes a trick bearing, and two, for this kind of use, off-road, going slow, OEM type bearings aren't a bad deal. They're better at embeddability than race bearings. Race bearings are really hard with a really thin overlay with a harder base. Like if dirt gets in your oil because of off-roading, they don't embed the dirt too well, and you can actually end up scoring your crank. With OEM type bearings, the dirt can get embedded within the material and not be sticking up and not start putting scratches and grooves in your journals. So embeddability is a good thing to think about when you're doing hardcore off-road. So we're not going to be spinning high revs, or not making 1,000 horsepower. So in this case, these type of bearings are fine. Now what we did do is we WPC treated them, which gives a 20% increase in load bearing capacity. So that's a good thing. So you're getting quite a bit more load bearing capacity, lower friction, and embeddability all in one package. Next, we got to talk about the camshaft. Now the camshaft is kind of like the brains of the engine in a way. So this kind of controls the power band and like a lot of the characteristics of how it's going to drive. Since this is a torque engine, we don't want to go too crazy. So this is a special cam that's designed for torque. The duration is really low. Like the duration is in the 250 something range at SAE. So that's only a little bit more duration than stock. But it has a lot of lift. It's just under 500 thousandths lift. So it's going to lift the valves pretty high, get decent flow, but your duration's going to be low. So you don't have excessive overlap and you don't have poor bottom end torque. So this cam is purely to enhance torque. We also cryo treated it and WPC'd it for long life and low friction. It's a really cool grind for what it is. Another thing to note, I guess, is this cam has a pretty spread lobe center. The lobe center is about 112 degrees. This means that the cam's going to idle nice. It's probably going to idle pretty close to a stock cam. It's not going to mess up your hydrocarbons that much for pollution, and it's not going to mess with your not too sophisticated fuel injection system either. So it's not going to have a bunch of pulsing and reversion and stuff in your intake track. So this cam is like a stock cam plus a lot though. It has a lot more lift, pretty close to stock duration, perfect thing to make more torque. Finally, we have the cylinder head. Now, in our race motors, we spend a lot of time massaging the head, getting every bit of flow out of it. We don't care about bottom end too much in particular, but in this Jeep motor, we worry a lot about bottom end and, not making the thing too undrivable. In fact, we want to enhance bottom end. That's going to really help when you're putting down the trail or doing crawling. So what we've done here is we've done a lot of things to enhance flow, particularly low lift flow, and not really compromise the torque or the bottom end. First thing we did is we kind of laid back the combustion chamber around the side of the valves so we don't have valve shrouding, and we like these old domestic engines are kind of crude in the way, so we got some cartridge rolls and cleaned up the combustion chamber. Now you notice that this head has generous quench pads. This kind of matches the dish on the piston. So why this is important is these quench pads actually, as the piston comes to top dead center, like all the dead areas of the combustion chamber, it like squishes the fuel air mixture closer to the spark plug. This ensures better combustion and makes things less likely to detonate. So you can imagine the fuel air mixture getting squished out of these dead zones, like here and here, especially here, far away from the spark plug, and shoved toward the spark plug. And it's going to be like putting your finger over the hose, so it'll be kind of squirting out of there. That's going to cause a lot of turbulence in the fuel air mixture before ignition. Good mixing. You're not going to have a stratified mixed charge around here. It's going to be more homogeneous, so that means better ignition, less likelihood of detonation, better power even, with no compromise in bottom end. So it's a nice little touch. So we're running like stock-like valves. We don't need to have anything super tricked because this isn't a race motor. It's not going to rev. But we did pay a lot of attention to the valve seat. So it has a radius valve job from a Newen CNC machine, continuous radius. That really helps low end power. It also helps low lift flow. So that's going to help without hurting anything. I keep talking about low lift flow. Low lift flow is like where the valve just starts to open and just starts to close. This is the most important kind of flow to get because the valve spends more time around the bottom. So when the valve's opening and closing, a lot of people like to brag about how much peak flow they get, but that's the valve's only at peak flow once, but it's at low lift zone twice in every opening and closing cycle. So there's more time spent around low lift. That's why in our builds we always stress low lift flow as being the most important, even though the peak flow looks really good in those advertising numbers. When you look at the ports, we didn't really do a whole lot. Basically, we just kind of matched the port to the gasket, cleaned it up with some cartridge rolls. We didn't want to make the port really big because this isn't a race engine. We just want good port velocity to make good torque. Basically, we cleaned up the short side radius in the intake and exhaust ports. And a lot of these old school engines, that's really a sharp ridge usually. You just want to kind of break that edge and blend it. That picks up a tremendous amount of flow without hurting your velocity or your torque. The other thing we did is, so where your radius valve job ends, we wanted to make sure that that part blends into the port bowl smoothly. These old school engines have a lot of core shift and a lot of unequalness there and a lot of rough casting stuff. We just cleaned that up, and we also kind of cleaned the entrance up of the bowl into the port itself, like clean up the short side radius and clean up that entrance. And we're hardly removing any material, but this stuff like probably comes close to almost doubling the port flow with no decrease in velocity and no decrease in torque. Like what a lot of guys do is just hog the ports up real big. That's good for top end, but then the velocity goes down and you lose bottom end. What we did is got tremendous flow gains just by elementary cleanup, simple work, and that's not going to hurt torque. It's probably going to increase it because we're increasing that low lift flow so much. One of the things that kind of sucks about this engine is it's not a cross flow, it's a side flow. So the intake and the exhaust ports are on the same side. Now I guess that's because it's an old school engine and it's done for packaging reasons. But instead of the flow going across the head, it's going in and out, kind of having to make a U-turn. Maybe that's another reason why we specified a wide lobe centerline on the crank, so you don't have too much reversion going on and impartial scavenging because of this side flow head. That's another thing to keep into consideration. For the valve train, we used beehive springs as recommended by the cam manufacturer and some lightweight retainers. Beehive springs are good because the coils, the tightness of the bend and everything changes continually through the coil, so that way you don't have to worry about them developing a resonance or surge. It's not that big of a deal with this engine that's not going to spin too high, but it's a really cool thing, and that's kind of like why beehive springs are kind of a hot commodity now, and now you know why they're better when it comes to like all engine building. But we got the beehive springs, we got the umbrella type valve seals. We didn't want to do anything trick, just stuff that's straightforward, that's going to seal good and not smoke. Lightweight retainers are nice, but they're not absolutely necessary. This engine isn't going to spin too fast. With the short duration and high lift though, we are going to get pretty decent valve train velocity, so we do have to pay some attention to reduce the possibility of float, but I think that's about it. The rest of the stuff is pretty much stock, but I think we're going to come close to getting maybe about 50 to 60% more power out of this little motor, a lot more torque. No loss in bottom end. Probably fuel economy won't change that much, and it'll idle nice and smooth just like a stock motor, and it'll be a great thing for trail driving. So we just don't build race engines. Like there's different kinds of focuses you want to do. This is a low end torque motor, so we're focusing on that. It's not sexy with all kinds of crazy parts like some of our other motors, but this will do the job real nicely. So if you like this content and want to see more, be sure and hit the old subscribe button, and also comment and exchange with us. If you make some comments or ask questions, we'll do our best to try to answer them. And if you're interested in getting your engine built for whatever your use might be, go to MotoIQ.com. hit the garage services link and you can fill out the sheet. We'll get back to you. And while you're at MotoIQ, why don't you check out some of our cool technical articles. I mean, we get more in depth than this, and if you're a gearhead, you're going to love it all. So until next time, we'll see you later.